little issue, if you remember from in class, trying to do number 5. We finished in class, but I wanted to update the recording so that there's a recording for number 4 and number 5 separately as opposed to them being together. So I apologize for that. But let's try number 5. So in this question, we're looking at Sasha, and it tells us the probability that she will experience a delay due to traffic is 0.2. It tells us that each day can be considered independent of the other days. For the next 21 days that Sasha travels to work, what is the probability that Sasha will experience a delay due to traffic on at least 3 days? So in class, we talked about how this is the most basic way to start describing a Bernoulli trial. We talked about Bernoulli trials at the end of the first semester. We had 3 things that had to be true. We needed to have either success or failure. So in this case, Sasha is either delayed due to traffic on her way to work or she's not. Then the second thing was you need a constant probability of success. So in this case, the constant probability of success is 0.2. I mentioned in class, I'll mention it again, that, in this case, a success is being delayed due to traffic, not really a success in life. And then the third component for Bernoulli trials is that you have independent trials. In this case, it says each day can be considered independent of the other one. So this checks all the boxes for Bernoulli trials. And then in class, I mentioned how this is going to then decide, is this geometric or is this a binomial model? So geometric is when you're waiting to get the first success, like we talked about in letter B. And in letter A, this is talking about the number of successes out of a total number of trials. So this is actually a binomial model. So kind of the first thing that should happen if you're doing this on the AP exam, that when you read this, you should think this is describing a binomial model. Okay, so now in order to do this, I need to find the likelihood. Let me start off with here. It's saying at least 3. So at least 3 of 21. And we talked about in class when we recorded this, that means 3 out of 21, 4 out of 21, 5 out of 21, all the way up to 21 out of 21 that she's delayed every single day. All right. Now, when I taught you guys this in December, I said that when you see those keywords, at least, that you want to think about finding the complement of this and subtracting it from 1. So I'm going to do 1 minus, and the complement for at least 3 out of 21 would be finding the probability that she's delayed 0 times out of 21, 1 time out of 21, or 2 times out of 21. And if we go into the computer, the calculator, excuse me, we can actually have it type out using the function that I showed you guys, the binomial CDF. All right. I don't want you to really focus on writing down calculator like functions on your paper when you're answering the AP exam. I'm just writing it here to show you which one I'm going to do. Okay. So in this one, I'm going to do second vars, which is distributions. I'm going to scroll down to binomial CDF. Now there's 2 binomials. I'll show you both of them. There's binomial PDF and binomial CDF. The only time you'd be using binomial PDF is if the problem had said exactly 3 out of 21 times she's delayed due to traffic. When it doesn't give you like a range of values, then you want to use the PDF. But CDF is when you have a range. In this case, my range is 0 out of 21, 1 out of 21, or 2 out of 21. So I have to enter for CDF. And you can see it's all in here, 21 trials. My probability of success is 0.2. And when I mentioned this in class is if you type this in, it's going to give you every single value that's to the left of the one you type in. So it'd be 0 out of 21, 1 out of 21, and then the one including it, 2 out of 21, which is what I want. So I'm going to hit paste. All right, so type this in. And again, this is not the answer. This is the likelihood that Sasha is delayed due to traffic on none of the 21 days, on 1 of the 21 days, or on 2 of the 21 days. So 0.78 or 179. So 1 minus this number will give us our answer. So if I do 1 minus this answer, I'll get 0.821. And that's the answer. All right, part B. What is the probability that Sasha's first delay due to traffic will occur after the 5th day of travel to work? So this is a geometric model idea because we're waiting for her first success. So in this case, it's going to be first delay, which is a success, after the 5th one. Okay? So that means for the first 5, she's not delayed. So that means for 0.8, which is my probability of failure. So she's not delayed on 80% of the days. So 0.8 to the 5th power is actually all you have to do to find the answer for this problem. So 0.8 to the 5th power, which is 0.328. Okay. Now, last one, part C. It says we have a random sample of 21 days. That's the same number. That hasn't changed. All right. For the proportion of those days that you will experience a delay due to traffic, is the sampling distribution of the sample proportion approximately normal? And this is essentially saying, okay, if we're going from binomial and we want to go ahead and say that it's a normal model, we have to check the success failure condition. All right, so this would mean that we'd have to do n times p and n times q, and we need to get numbers that are 10 or more. So 21 times 0.2 and 21 times 0.8. All right, if you do 21 times 0.2, you get 4.2, and this one you get 16.8. Now, unfortunately, not both of those numbers are 10 or more. So because both numbers are not 10 or higher, it's not appropriate to use a sampling distribution model of the same proportion being normal. So the sampling distribution model for a sample proportion is not approximately normal. All right, guys, and that's it for this question number 5. Now, in the next video, I'm going to take some time to go through the investigative task. And as I mentioned in class, it's not, I mean, you can watch it if you want. It's just like the investigative task is not something that you can kind of recreate. It takes everything you learned in stats and tries to extend it to something new. So it's not like it's a bad thing to watch, but the investigative task will most likely not be like the one we're going over. All right, good luck.